Hi, welcome again, and we're going to go over some problems from your Test 3 review. Pardon the title. I stole this from when I taught trigonometry at another school. So, before you start, please make sure to have a unit circle handy. So, I posted one, I believe, maybe about at the end of October when we started going over Chapter 5. But you can always Google a unit circle if you like. I like the one that I provided for you because it gives you a lot. It gives you the values for sine, cosine, tangent, and their inverses. It gives you special values of special triangles. It also tells you a chart with all 6 trig functions in the first quadrant. So I think it's a very helpful chart. All right, to begin, let's start off by doing some problems. For the sake of not making the video too long, I'll only go over some. So the first part, and something you'll see a lot, is you're being asked to evaluate. Now this is just as easy as looking at unit circle. So sine of 150. To figure out sine, we're going to use the fact that the point xy tells us the x is cosine and the y is sine. So we look at a unit circle, we find the number 150, and we see the point negative square root of 3 over 2, comma 1/2. That 1/2 is sine. So our answer is 1/2. All right, now I want to show this example F because our unit circle only goes from 0 all the way to 2 pi, or 0 to 360. So if the number is not between 0 and 360, we have to change it so that it is. So if the number is bigger than 360, you're going to have to subtract 360 a number of times to get there. So let's do some work. So we have 600 minus 360, one revolution. So you can go ahead and figure that out. And you see that you get 240. Now you ask yourself, is this number between 0 and 360? It is. Now you can find it on unit circle. So you check your unit circle, 240. It's somewhere down here. And 240 gives us a coordinate point, negative 1/2, and negative square root of 3 over 2. Now secant is 1 over cosine. So if we have cosine, we have to figure out 1 over divided by 1/2. And that just gives us 2. So my answer is, well, that was negative 1/2. Our answer is negative 2. So to show that work, we have 1. You can rewrite as a division. So 1 divided by 1/2. Remember to divide fractions, you multiply. 1 times 2 over 1, which is just 2. So that was that little math. And don't forget your sign. So answer is negative 2. Another problem is cosine of negative 240. So when we see negative, it just means that instead of going counterclockwise, we go clockwise. When we go clockwise, it's negative direction, but it still gives the same value. Now, if that throws you off, you can change the number so that the number is between 0 and 360. So to change it, to make sure that it's between 0 and 360, you can go ahead and add numbers until you get there. But not any number, you're always going to add or subtract 360. So negative 240 plus 360, that gives you 120. So you look at unit circle, look for the number 120. It's that first little tick mark right here. And that's a coordinate point, negative 1/2 and square root of 3 over 2. So our answer is cosine. We want cosine of the value of 240, which is the same as cosine of 120. So cosine at 120 is negative 1/2. Our answer is negative 1/2. All right, let's go ahead and do the second part. Now here notice that we have pi's. So this is our radian measure. If you look at your unit circle, you have both degree and radian. Radian is made up of fractions that take up our whole circle from 0 all the way to 2 pi and divides it into slices, I guess you can say, into pieces. And those are the fractions that make up our unit circle. Now, if you do not like radian measure, you can always change it to degrees. So to change it to degrees, you just convert to degrees by multiplying by 180 over pi. So I'm going to do one example here because it's exactly as we did above. Cosecant of 2 pi over 3. So if this throws you off, well, actually you can just go ahead and look your unit circle, find 2 pi over 3, and try to find cosecant. If it throws you off and it's not within the unit circle, you can always convert it. So for this one, I won't convert it because we convert in a different part. So at 2 pi over 3, that is the same as 120. And you'll see that value 2 pi over 3 and the number 120 next to it. That's negative 1/2 over and square root of 3 over 2. Cosecant is 1 over sine. So we get our sine, which is a y, right, as 1 over square root of 3 over 2. Remember, that's just division. So if you don't like, you can always write it. 1 divided by square root of 3 over 2, which is 1 times the reciprocal 2 over square root of 3. So our answer is 2 square root of 3. But remember, we have to always rationalize. So our answer is 2 square root of 3 over 3. All right. The same thing for the rest of them. Now here we want to convert to radian or degree. To go from radian to degree, you want to multiply by 180 divided by pi. To go from degree to radian, other way around, you want to multiply by the reciprocal, pi over 180. All right, so first we have 200, and we want to convert it to the other. So we want to change it to radian measure. So we have to take that 200 and multiply it by pi over 180. We multiply across and you get 200 times pi divided by 180. So all we can really do is simplify that fraction. So 200 divided by 180, that simplifies to be 10 over 9. So I have 10 over 9 pi. Now here, because we have a pi, we know we have a radian measure, and so we want to change it to degree. Another indicator is it doesn't have little degree symbols, so I know I'm not working with degrees. So I'm going to take 7 pi over 9 and multiply by pi 180 divided by pi. Notice your pi's cancel. And we're left with 7 times 180 divided by 9. And simplify where you can. You can simplify that. 180 divided by 9 gives us 20. So I have 7 times 20. That gives us 140. So our answer is 140 degrees. For the next problem, we want to, for each base of the given function, find the values for theta where theta is between 0 and 360. Okay, so I want to find the degree given the answer. Now it's telling me the quadrant we're in. That's important because that will let us know whether it's positive or negative. Remember, all students take calculus. So this means all functions are positive. Here only sine and cosecant are positive. In the third quadrant, only tangent and cotangent are positive. And in the fourth quadrant, only cosine and secant are positive. So we're in the fourth quadrant. In the fourth quadrant, only cosine and secant are positive. So it makes sense that's negative 1/2. So you want to look at your unit circle. When is sine negative 1/2? So you look at the fourth quadrant, and negative 1/2 for y is at right here at 330 degrees. We see we have the value of square root of 3 over 2 and negative 1/2. So our sign is negative 1/2. So our answer is theta is equal to 330 degrees. And we're using degrees because we have the degree marker. Okay, let's take a look at a more challenging one. So the reciprocal functions along with tangent are not given in the unit circle. In the unit circle, it's really easy to pick out sine and cosine. The rest, not so much. So if we're looking at the third quadrant, and I want to see where cosecant is negative square root of 3. Negative 2 square root of 3 over 3. So I know it's going to be negative because in quadrant 3, cosecant is negative. Only tangent and cotangent is positive. But what angle am I working with? So if we're using the unit circle I give you, we see that cosecant of 60 degrees is equal to 2 square root of 3 over 3. So this means that if I look at my unit circle and I look at the one that has a 60-degree reference angle, that would tell me the angle that would give me the negative 2 square root of 3 over 3. So the 60-degree reference, that would be the value. So I have 180 plus 60. That gives us 240. So my answer is theta equals 240 degrees. For 5, same idea, but we're being asked to work with radian measure. For the given following information, find t. Notice the restriction on t is not necessarily the same for each exercise. So here, it's telling me that I want to work between pi and 2 pi. So I'm only looking at the bottom half of my value. I want to find where secant is equal to 1. All right, well, what is secant? Secant is 1 over cosine. So I want to find where cosine is 1 because 1 over 1 will give us 1. And we see that cosine is 1 only at 0. So my answer is 0, but we want only from pi to 2 pi. So our correct answer would be t is equal to 2 pi. Okay, next is graphing. So for your test, you're not necessarily going to have to graph from scratch, but you should be able to know some important parts of your graph. So to begin, let's list some pieces. So I ask for your amplitude. Your amplitude is how high up your graph goes. Your amplitude is given by that number. Is it reflected? If it were reflected, that would be a negative in the front of your trig function. So no, it's not reflected. This -1 is just a shift down. The frequency is this number here, so 3 over 4. Your period will be made up of 2 pi over b. Our b is at 3 over 4. So let's go ahead and figure that out. So I have 2 pi divided by 3 over 4. That's just division, so let me rewrite it so it can be more pleasing to the eye. So 2 times 4 is 8, 8 pi over 3. This is my period. So my answer is 8 pi over 3. Now your period is going to range from 0 to 8 pi over 3. So I want to go ahead and split that into 4 different pieces. To split that into 4 different pieces, I'm going to divide it by 4. So 8 pi over 3 divided by 4, which is the same thing as multiplying by 1/4. So 8 pi over 3 times 1/4, that means we have 2 pi over 3 between each tick mark. So go from 0 to 2 pi over 3, and then I'm going to add another 2 pi over 3, so it gives us 4 pi over 3. I'm going to add another 2 pi over 3, so it's 6 pi over 3, and then I'm at 8 pi over 3. Now you can do a chart to figure this out, but you know a lot from cosine. Cosine functions, unless they're shifted, start at 1, go medium point, low point, medium point, back to 1, and that's 1 period. Now our function goes to an amplitude of 2. So I'm going to draw a little ghost one first. So I start at 2, go to 0, go to -2, back to 0, and go to 2. But because I'm shifted down 1, I'm going to shift each one down 1. And there we have our graph. And that's part of our wave function. Now, if you don't trust me, which I totally get, I kind of rushed through this, you can go ahead and plot each one of these points on a chart so that you have x is equal to 0, 2 pi over 3, 4 pi over 3, 6 pi over 3, and then from there you'll see that they start repeating themselves. And plug them into your function. -1 plus 2 cosine of 3 over 4x. So we plug in 0 first, for example. -1 plus 2, that's just 0. Cosine of 0, cosine at 0 is 1. So I have -1 plus 2, we get 1. So we first have the 0 and 1, which is this point here. So we're good so far. And then you can go ahead and work them out, and you'll see they'll get all these points in return. So you know what works best for you for graphing. I kind of just rushed through it and used the fact that I know how cosine looks, or that we know how the cosine parent function looks, and just shifted each point down 1 because we have a shift down 1. Now, if you have summation or subtraction within your cosine argument, then you have a horizontal shift. To find your points for one period will vary. It won't be as easy as just taking your argument for cosine and dividing it by 4. I'm sorry, taking 2b and dividing your cosine function. It's a bit more involved. You have to create a compound inequality from 0 to 2 pi and solve for x. If it's a bit more involved, so that's when I would totally suggest you look into your notes. This was 6.1 part 2. And I kind of quizzed you kind of heavy on the graphing, so I won't go so heavy on it for the exam. Your review has some inverse functions. It's not on your exam because that's technically something we saw in chapter 7, I think. So I'm not including on the test, but it's in your review, and it's good to know. It's just kind of the backwards of evaluating like we did in part 1. All right, last piece. Let me do 10A. So there'll be a problem where you might be asked to evaluate. All you're doing is plugging it in, just like you did for when you graph and you did a chart. So you want to find f of pi over 2. So that means we're going to plug in pi over 2 for t. So we have -3 cosine of 2 times pi over 2. Because we had 2t, we're letting t be pi over 2. And it's just algebra. So my 2's cancel and make 1, so I'm left with -3 cosine of pi. Cosine at pi, we look at a unit circle, we look at pi. Pi is the point -1, 0. Cosine is the x, so I have -3 times -1. My answer is just 3. So we're just doing some substitution. All right, this is your test. Now for your test, like always, I'm not monitoring you, so have your notes out. Do all of your homework before you start the test. Your test is really good practice. And for sure, have a unit circle handy. Now, if we weren't online, I wouldn't be providing a unit circle because I would be testing you like every day so that you would memorize it. But there's no way for me to really truly enforce that since we're online. So have your unit circle out. That's something that will make this test super much more easier for sure. All right, that's it for your review for test 3. Best of luck. If you have any question as you're reviewing, feel free to email me. Thank you.